I'm Tejas Kumar, and I've been building on the web for over 20 years at places like Vercel, Spotify, Zeta, and more. Today, we're going to talk about AI today and how you can make it applicable to you today. And I could present at you, but that's not, I feel like it's not as personal. So instead of presenting at you, I'd love to just talk with you using my slide deck as the basis of a discussion. But I'm just gonna let's look at the slide deck together and have a conversation. Okay. So with that, let's just start by talking about AI today. And we'll talk about AI today through the lens of AI fatigue. Okay. What does that mean? Well, there's just AI everywhere. And some people are expressing that it's just way too much. There's high valuations, there's a lot of hype, there's a lot of AI this, AI that, there's a lot of overpromise and underdeliver. And I think a great like evidence of this is my friend Stephanie, who says, "Dear brands, companies, etc., I do not want or need AI injected into every single part of my life. At this rate, I'm more likely to use your product if you're not shoving AI down my throat. Okay, thanks, bye." Right. And have you been there? Like, do you feel that? I feel that. I feel that when there's devices like the R1, the Rabbit R1, that's claiming to do a bunch of things, and then I get it, and it doesn't do that. I even feel that with Apple. I was promised Apple Intelligence. I bought the new iPhone. This is the 16 Pro Max. You can tell with the camera control, which right here. In any case, um, and it doesn't have Apple Intelligence, and I live in Europe, and so how long is that going to go? There's a lot of overpromise, underdeliver, and just AI, AI, AI everywhere, and it's really exhausting. And I want to start our discussion by just making this metaphor that let me know if it tracks. AI should be, and AI features should be like salt. Um, they should be like salt in that you use them with taste and sprinkle them on your products, and you can create true beauty and flavor. But if you drown your thing in salt, people get sick, right? And that's sort of what we're starting to see. So just off the bat, let's acknowledge that AI is not the silver bullet to everything. There's a time and a place, and let's explore what that appropriate time and place is in our time together today. Okay. Um, I talk to a lot of people. I have a podcast. I literally talk to a lot of people there, but I also speak at many conferences and just constant conversations. And I take the opportunity of talking to all these people and ask them, hey, do you think you could be an AI engineer? Do you think you have what it takes to be an AI engineer? And the vast majority of people respond with, no, I don't think I could be an AI engineer. I don't think I fit in the AI space. I don't think I could play. And it's interesting because I ask why, and they say, well, I don't know linear algebra. I never went to university. I'm not Harper Carroll. I never studied this at Stanford. It's too academic, too much math. They usually say something like this. I don't know Python, right? Um, and this is very interesting and surprising because AI engineering has nothing to do with those kinds of topics. And this is not my opinion. There's been a number of guests on my podcast who agree with this. People like Harper Carroll and on a separate, on PodRocket, which is a different podcast. Malte Ubel, I had a conversation with him. He said the same thing. People don't understand what AI engineering is and often confuse it with machine learning. So let's talk about AI engineering specifically. Um, the title AI engineer is a job title that Swix, a friend of mine, Sean Wang, outlines very well in his blog slash newsletter slash podcast called Latent Space, where he's got this diagram, and it's a diagram going from left to right. And on the left end, you've got data and research, which is things like machine learning research and machine learning engineering, which you do need Python for because you're training models, you're doing a lot of math. There's a big line down the middle, which is the API. And beyond the API, you've got AI engineer and full stack engineer. And an AI engineer is one who literally is specialized in that part of the full stack. What that means is they communicate over an API to some machine learning model. They don't program the machine learning models themselves. In a very crude way, you could say that it's like using JavaScript's fetch API to talk to OpenAI, get a response, and solve a problem. If you know how to use JavaScript fetch, indeed you could be an AI engineer. It's literally that. It's talking via an API to some machine learning model, not necessarily training the model itself. It's applying AI, not creating AI. It's applying machine learning, not creating machine learning models. And so once that distinction becomes clear, if I ask you again, do you think you could be an AI engineer? That should probably start to change, right? Because again, if you know how to make a network request in Python, JavaScript, Java, whatever it may be, you can make a network request to a large language model as a service over an API and then get an inference and do something with that. That is AI engineering. And an extension of AI engineering is full stack engineering, which is engineer across the entire stack where AI is a part. Now, some of you may think, wow, this is a very different definition, and I didn't know that. And how dare you? You're simplifying AI way too much. But this is not a claim that I make, right? This is in Squix's blog called Latent Space. This is also things that other people say. And if you look at the bottom of this blog post, or at least read it or listen to it, there's this quote which says, in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers or large language model engineers. One can be quite successful in this role without ever training anything. And the person who says this is Andrej Karpathy. Andrej Karpathy. Who is Andrej Karpathy? Andrej Karpathy was a co-founder of OpenAI, the company behind ChatGPT. If anyone is in a position of authority to make such a statement, it is definitely Andrej Karpathy. And he says, literally, one can be quite successful as an AI engineer without, and I quote, ever training anything. Okay, and so do you think you could hypothetically be an AI engineer? The answer is probably different than it was before. Okay, so let's talk about AI specifically. This word is everywhere, and a lot of people are saying a lot of things about it. There's a lot of valuations that are very high. There's a lot of salaries that are very high. What is AI? AI has existed for a long time. I grew up playing the old Mortal Kombat games, with Liu Kang and Kung Lao and Scorpion Sub-Zero. Mortal Kombat 1, the first ever one. This is why I'm so messed up, because I played that as a child. In any case, this game had artificial intelligence. It had simulated intelligence, right? Like the punches and the kicks by the CPU player were literally simulating intelligence. However, that is an example of rule-based artificial intelligence. The rules are known ahead of time by the programmers. If you hit here, you cause damage, etc. It's a bunch of if-else statements, right? And these rules are known ahead of time, and they're put into the program by the programmer. It's rule-based AI. It's still a kind of AI. It's been around for a long time, but it's AI nonetheless. The second type of AI that we see very commonly today is called predictive AI. And that's things like Markov chains. Like on your phone, you've got your virtual software keyboard, and just above the top row of keys, you've got suggestions. Um, some of you may have played this game where you just repeatedly tap a suggestion, and what you end up with is a nonsense sentence. And that's because these predictive models are just a big Markov chain. A Markov chain is a statistical model where it predicts the next state based on the current state, and it can predict the next state from a big pool of possible states. But the key feature of the Markov chain is that it's unfortunately embodying the Markov property, which is just a fancy way of saying it's memoryless. It doesn't have attention on all the previous historical states and all the possible states. And so you can only predict the next one based on today. Of course, in practice, that doesn't really work, right? That's like trying to predict tomorrow's weather only based on like today. And we'd get a much better prediction if we try to predict tomorrow's weather based on the past month's weather, based on the past year's. The more data you have, the better predictions you can make typically. This is also why if you're trying to predict the next word in a sentence, you can only get so far with the current word in a sentence, and you can get way further with many words in a sentence. And this is really why we need good AI. Okay, what is good AI? Well, the third kind of AI is called deep learning or machine learning. And this is the thing that is hyped and that everyone's talking about, deep learning, where when you hear the term deep learning, it just means that somewhere there's a neural network being used. Okay, what is a neural network? It's literally what it sounds like. It's a data structure, a big data structure that models the human brain. We think of the human brain. If we think about eyes, right, which the neural retina is a part of a brain. So an eye receives light, turns it into electricity. The electricity and chemicals work together through some quote unquote hidden layers in the brain, and this makes its way to our periphery, to our bodies, and we understand what we see this way, and that works itself out through outputs, through actions that we do. And it's very similar that when you model this with computer, you have an input layer. In the case of the human eye, this is light, that then goes through multiple what are called hidden layers. This is basic deep learning architecture. Hidden layers can be considered analogous to neurons in a brain, right? Each layer is made up of a list of numbers, and these numbers are initialized with what are called empty weights. And there's a number of mathematical operations that execute on them to help get to the right output. And so when you train a model, you give it a bunch of input and output pairs, and then the computer fills in the blank. In these hidden layers, it does the work to really fine tune a very careful algorithm, aka discover the rules, to arrive at the output you've chosen in your training data. And over time, this in the hidden layers, which is just a big mathematical matrix, a big list of numbers, you can save those lists of numbers, aka the weights, and that becomes your model. That's deep learning. Now the cool thing about deep learning is there's many different kind of model architectures, and that just means a different arrangement of these hidden layers. There's long short-term memory style architectures, there's recurrent neural network architectures, and there's convolutional neural networks. All of these are just different arrangements of hidden layers, and they have different specialized cases. For example, convolutional neural networks can detect features and images very well. And this is how you take an image, like even me right now, you make it black and white, and you highlight where the light falls, so you get a nice outline. And based on the outline, you can decide what is what, right? And so there's different architectures tailored to different things, and all of this is becoming relevant because there's a specific architecture called the transformers architecture that became very famous and gave rise to ChatGPT, among other things. And so this finds itself in a paper by a ton of Google brain scientists. Now, they're not actual brain scientists on the human brain, it's a department of Google. And they published a paper called Attention is All You Need. And this paper outlines the transformers architecture, which in a very simplistic term is a way of modeling attention. It's a way of modeling attention. And so multi-headed, highly parallel attention, where instead of like Markov chains, the current state is used to predict the next one. In with the transformers architecture, you have an input token, which is roughly equivalent to an English word. And the architecture is such that a computer can model multi-headed attention to the token or set of tokens and the surrounding context around the token in parallel. So you're capturing features for each word and its surrounding context and using that to train the model. Therefore, you can then generate or create very high quality, contextually relevant outputs, which is exactly what a model like GPT-2, GPT-3, GPT-4, ChatGPT's underlying models. That's what they all do. Is they just give you nice cohesive sentences by virtue of this model architecture. That's how that works. Okay. And why are we going into this much detail? Because it's very important to understand how this works so we can talk about how to apply it daily. Okay. So you had transformers all you need, excuse me, attention is all you need, and that gives rise to generative AI. Some would call it Gen AI. But if we've been around long enough, we know that Gen AI has a ton of limitations, right? Can we think of some, like right now? Probably the biggest one is that it hallucinates, right? Like if you go on Google, outside of Europe, we don't have the AI overviews in Europe. And if you ask, how many rocks should I eat per day? You'll Depending on the day, you'll probably get an answer that says you should eat 3 rocks per day, 3 small rocks per day. And that's because the training data contains the internet, which contains jokes and nonsense. And so it's very sometimes plain for a large language model to just predict the next word, which sometimes can be misinformation and quote unquote see what's not there, aka hallucinate. Hallucinations are a huge problem. Problem number two is knowledge cutoff. GPT-4 finished training in April of 2023, if I'm not mistaken. We are in October of 2024. There's a significant latency there, and it just doesn't know 2024 information at all. You ask for 2024 information, you're going to get an old result, specifically if you ask the model directly. And we'll talk about ways we can mitigate this. There's also finite context. The largest quote unquote context window in a model is Gemini with 2 million tokens. Again, a token is roughly equivalent to one English word. And so, with this 2 million token context window, roughly 2 million English words, you have to ask, okay, but like, what can I actually do with that? Right? Because like as you start approaching these limits, the model will behave unexpectedly. And so is that enough? And finally, probably another limitation is that it's just not human, right? And so it can't love and be creative and irrational like we are. It's not designed for that. Okay. So I want to talk to you about a way we can solve making AI applicable today, useful today. How can we overcome these limitations and actually build great tools, great products, great software? Um, there's one technique that can overcome all these limitations, and that technique is called RAG. RAG stands for retrieval augmented generation. Retrieval augmented generation. What does that mean? It's basically prompt engineering. This will get me in trouble, but that's what it is. So you retrieve, again, retrieval augmented generation. You retrieve real-time context. You retrieve authoritative good context. How do you retrieve it? I don't know. You just search the web, or maybe you have a database with actually authoritative. Either way, you get good content, quality content that is not hallucinated. You get this data and you include it in your prompt as context. That's it. That's so you retrieve context, include it in your prompt, and then ask a question based on the context. And that augments, aka changes, the generated text. Retrieval augmented generation. That's it. RAG oftentimes is just prompt engineering, where you inject current real world authoritative context into your prompt and then ask a question. How might this look in practice? Well, if you have, for example, if you want to convert, like 100 euros into Mexican pesos, right? And you go ask a large language model how to do this. Say, I don't know. I don't have today's exchange rate. So if you wanted to do RAG, you go retrieve today's exchange rate from somewhere on the internet, include it in your prompt. Hey, here's today's exchange rates. Now you ask your question. Convert 100 euros to pesos, and it will do it. That's literally RAG. You just include context in your prompt. Um, let's look at how we can actually do this in practice. Now, I work at DataStax, and we make a tool called Langflow. Langflow is sort of a visual builder for AI applications, and I'd love to show you that. And by doing that, we'll also talk through some components of RAG, specifically data, which is, we already talked about authoritative data like the exchange rate, embeddings models, and a vector store. Embeddings models and vector stores are sort of intertwined. And we'll see this in practice, but right now an embeddings model is just a specialized machine learning model that can take natural language, so a sentence, a paragraph, and convert it into a big list of numbers, vectors, aka coordinates, and then embed them in high dimensional space. We'll talk about what that means. But with an embeddings model, you're going to get a big list of numbers, which is called a vector, and then you need to store this vector somewhere, aka a vector store or a vector database. And again, let's talk about this. Let me just show you what I mean by embeddings models and embeddings and vectors. So if we consider two-dimensional space, right? Two-dimensional. So this is two-dimensional space. If you're watching, now's a good time to actually watch instead of listen. And in this space, you've got words like dog and cat and mouse, right? And maybe mouse is a little bit further from dog and cat because it's not really a pet, depending. And then you've got words like boron, and helium, which are chemical elements, right? And then you've got words like iPhone, and they're all like scattered in space. They're all in different positions. Um, and an embeddings model will take words in natural language and literally embed them in space, in this case two-dimensional space, closer to what they mean. And then when a user comes with a query to do some type of lookup, when the user is like, what pet should I get for my tiny house, right? Then the database, the vector search engine can be like, okay, so you have pets here. That means I'm going to go look in this part of the database. I'm going to go look close to the dogs and cats, and it will yield you literally those results. That's how vector search works, is words become numbers, and then they're searched in a database that is specialized in vector search, and you get back relevant records, okay? Let's look now how we might actually perform RAG and make AI applicable today. We'll do that using a tool at DataStax we create called Langflow. So if we like go to the fundamentals of what how a chatbot even works, is you have a chat input, right? And you have a prompt that you construct from the input. We won't let's just give the chat input to the large language model. You have a model like something from OpenAI, right? And you have a chat output. And so that's really how any application works. So you have a chat, you have an LLM or large language model, and you have an output. We'll connect the chat message to the input and the output to the chat output, just like this. And just like this, we've modeled a large language model. Let's use a cheap model like GPT 3.5 Turbo. And now if we visit a playground and we ask a question like, which movie won the Oscar for Best Picture in 2024, right? And if I send this, the model is not going to know. I'm sorry, but I'm unable to provide real-time information and I don't have access to current data. That sucks. And this is one of the limitations of large language models. Again, the model alone. RAG helps us get real-time data. Let's look at how RAG works. And then we can even look at some places RAG is used in the wild. So how would we model RAG here? Well, for starters, let's get rid of this. We have our chat input. We need some stuff in between our chat input and our large language model. Specifically, we just talked about this. We need an embeddings model. I'm going to go ahead and use OpenAI's embeddings, just like this. We need a vector store because we need to search something, right? And AstraDB is a vector store that we make. And we need to construct a prompt from all of this. Okay, so I've got my prompt here. These are essentially all the components for a RAG application, a RAG Gen AI application. Okay, so how does this all work? Well, we have the chat input. We're going to turn this chat input to a search query for our database. We're also going to connect the embeddings model. Now, we're going to retrieve some results from our database that we'll need to convert to text. And for that, there's a component called parse data. We're just going to drag this, put it in our application. And that's because the database returns us JSON. And what we're going to do is we're going to convert that JSON to a string, literally like this. And then we include it as context in our prompt. So this is our prompt. This is the most classic RAG prompt ever. Given the context, and we'll create a variable, answer the question. And the question comes from the user. So watch, when I create these variables, there's going to be inputs here, context and question. So context comes from the database search, and the question comes from the chat input, just like this. Now we give this prompt to OpenAI. That's it. Let's talk to the right database. We have a database called RAG++, and we have a collection called Oscars. And we've loaded all the Oscar winners in there into our vector database, aka AstraDB. So now with this, we can actually go ahead and query our bot, which will get real-time context. So I go to Playground, and I'll literally just ask the same prompt in the Playground, which is which movie won the Oscar for Best Picture in 2024. And so now it's going to perform RAG, ask my database, look at this, Oppenheimer won the Oscar for incredible. We just solved it. Let's do even more. Tell me more about the Oscars 2024. It had no previous knowledge about this at all, right? And in, I don't know, a couple seconds, we have the answer, which is it saw the film Oppenheimer as the big winner, picking up 7 Oscars, best director for Nolan, etc. Also Coco and Neil Corbould were mentioned, etc., etc. So all of this, where is this coming from? And it's coming from our database, from here. In fact, you can see the search results. If I click on this, I can see that these were the search results. Oscars 2024, Oppenheimer is the big winner, picking up 7 Oscars. And I continue to get this data. Absolutely incredible. And so this is an example of how RAG is easy and how it can solve problems. What just happened? Did we train a new model? We did not. We have the existing model. We just gave new context in the prompt. And again, what is the prompt? The prompt is, given the context from my database, answer the question. You see, that's really it. That's how RAG works. We didn't train a new model. That's very important. We just gave new context. Where might we find RAG in the wild? Well, ChatGPT uses RAG. So if we go to chatgpt.com, this is literally ChatGPT. And if I ask, hey, what's the weather in Ukraine right now? It's going to, look at this, searching the web. It's retrieving data, and it's going to use it to augment the generation. See? For example, in Kiev, it's 10 degrees Celsius, etc. All of this is just retrieved from these sources. Even ChatGPT uses RAG because the model doesn't know. So what ChatGPT is doing is it's getting data and using it to augment the results. I have a podcast, and the search feature, you go to tage.as/podcast, the search feature uses RAG. So I type, tell me about resource hints. And now it's going to search across every conversation we've ever had and say we discussed resource hints at this time. And if I click play,
So I don't know how familiar you were with resource hints.
he literally says resource hints. RAG is great because it pulls in real-time data and allows you to make AI applicable today. Very, very cool. Let's talk about how we can continue to use this to build powerful applications. And I want to do that by talking to you about UX. See, because I don't like chatbots. I think chatbots are bad. I think chatbots are really not fun. I think they're just poor UX. I'm done with chatbots. I think we can do better. And so, what if we could instead create rich UX and using RAG? And so, I want you to consider an example with me, and then we'll look at the code of how it's built. Um, let's say it's the weekend and you're trying to find a movie to watch. You're trying to take your mind off things, and you go on Netflix and you try to search for a movie. Now, I don't know about you, but I don't think about exact movie names. Instead, I want to just, I just want to watch a movie. I know, like I want to watch a movie with like a romantic comedy in Europe, a movie with a strong female lead. This is how I think, right? I think of qualities. I don't think of the exact names. And so I love Netflix. I think it's a great tool. But if I go on Netflix and if I let's do it right now. So I choose myself and I'll type movies with a strong female lead. And what I get is there's no results. And it says the first suggestion is literally try different keywords. And that's really unfortunate because the way things work on the web today is just keyword search, and it's really unfortunate that it's keyword search because I wanted to understand me. And so to help ideate and brainstorm what a better search experience might look like, I created an application that I'd like to show you. It's called Movies Plus Plus. And it's what Netflix could be with Gen AI in RAG. So let's open it up. So it's actually running locally on localhost 3000, and this is Movies Plus Plus. And so you've got a UI here, and you've got some suggestions. And I'll just do that: movies with a strong female lead, right? And now it's asking Langflow, and it's going to give me a list of movies with a strong female lead. And that comes okay. So Wonder Woman, the 355. These are safe bets. But notice how this kind of looks like a chatbot, and how we agree that chatbots suck. We can do better, and this is what I want you to show, what I want you to keep in mind. Again, let's pretend that this is not a user using this, but an application developer, just in case. And so we can ask something like, what might this look like as UI, right? It's a prompt, but now if I hit enter, I get rich UI, which is so much more beautiful, right, than just a chatbot. I can click on it, I can go to the actual movie page, I can see who acted in it and so on. But it gets better. I could even ask for show me the trailer for Wonder Woman, and it'll start playing in line the trailer for the movie right here. Isn't that so cool? And so I can sort of watch this and think about. I could now ask the next question, like, what was the critical reception for Wonder Woman, right? And it will just answer me again in text, like it did. Um, I could do so much here. I could even um, ask for something like, where can I go to watch movies? And and here I get back the response, and I also get back a literal map showing me like walking directions. And it's fully interactive. I could be like, okay, cool, this is a movie theater called Movimento. I'm gonna go do this. Absolutely incredible. And you can see I get text when I need text, but I also get a map when I need a map. um, isn't this cool? This is so much better than a chatbot. Now, additionally, I want you to see the applications for customer support, because every time I do customer support with a robot, my initial thought, the thing I'm constantly thinking, show me a human. Show me, I don't want to talk to, because bots historically have been dumb. But what if it could be something like this? What if I wanted to say, I forgot my password. I need to change it. And instead of some nonsense, I just literally get the form to like change my password. So I type my new password, and just like that, it's done. You're all set, it says. And we go back to the homepage. Absolutely bananas, right? This is generative UI. And this is what I want to see. This is how we can make AI even better, especially given tools like React and so on. The code for the thing we just read, we were using the Vercel AI SDK. And so let's look at the code that does this. So we open the tool. It all lives in this file called ai.tsx. And what you can see is we're using this function called create AI. Create AI comes to us from the Vercel AI SDK, and we give it a large language model, some messages, but this is the real secret sauce. We have tools, and tools are functions that a large language model can call. And so, for example, get movies, a tool used to get a list of movies matching a user's query. We have a generator function that yields a spinner and then literally speaks to Langflow, gets the response, and sets it. And we return React. That's literally it. For the movie posters, there's a tool called Create Generative UI, and we literally just return a React component. It's just a React component. And so this is how it works. In fact, for the map, let's go look at the map. Or show forgot password. When the user says they forgot their password, use this tool and it returns you a function, just a React component. This is just a form with React, nothing special. The cool thing is I wrote this form. And so I have full control over what the LLM returns. Because again, it's not generating code on the fly. It's not generating a new component. It's just using my component. I say as a function, when the user says they forgot their password, return this component that I wrote. And that's it. How does this work? Well, as a human being, if you ask me to multiply 8 different prime numbers, I'm going to tell you I can't do that. At the same time, I know that there's a tool that can do that. It's called a calculator. And so I'll go use the tool. LLMs have exactly this. In their case, tools are functions, functions written by you. That's what I'm doing. I'm saying if the user says they forgot their password, then use this tool, call this function. The function just returns some HTML or JSX, and that's it. The cool thing about this is it brings a layer of determinism to generative AI applications. The output is no longer unpredictable, but actually 100% predictable because you give them the component. The LLM can generate props to your components, but the components themselves are written by you. In fact, if we inspect the show movie posters or create generative UI tool, what you can see is we get some movies as parameters, and these parameters are all generated by the LLM, right? And so that's the future I want to see. Imagine you're doing an e-commerce store and you've got product recommendations, but instead of creating a fine-tuned algorithm based on user preferences and stalking them like a creeper with cookies, um, if you just write a prompt, show me elements that this user likes, and it just generates UI for you, right? That's a future that is far superior to chatbots that I want to see. If we look at the movies plus plus Langflow flow, indeed this exists. If we go back, there's a flow in a project called movies plus plus. This is literally how it works. We get the chat, the query, we get AstraDB, we get the text input, we parse it. It's exactly the same RAG prompt, and it just totally works. And that's how that works. So we've seen the code with the Vercel AI SDK. We've seen Langflow, and I hope all of this helps you make AI accessible. Let's quickly fast forward and summarize all that we talked about. We started this discussion talking about how AI is overused, how frankly many of us are tired, and how we'd like to see novel and useful sprinklings of AI as salt as opposed to just overloading users. We looked at the limitations of AI. We even talked about what AI even is, right? Going from rule-based AI to predictive models to generative AI. We then identified problems with Gen AI, hallucinations, finite context, knowledge cutoff. And we explored RAG as sort of the silver bullet to solve these problems. And we even looked at how ChatGPT even uses RAG. RAG is the way. We then looked at how we can build RAG apps using Langflow with minimal setup. And finally, we looked at how we could go beyond the chatbot and actually create generative UI with a combination of DataStax, Astra, Langflow, and the Vercel AI SDK. I hope this has been helpful. I hope you are very eager and excited to build with Gen AI as I am, and I really can't wait to see what you'd build. And with that, I want to say thank you so much. Here are some links where you can follow me and continue to ask questions and so on. And I'd like to thank you. Thank you so much for being a part of this, and I look forward to talking more. Thanks again.